everyone. Welcome to Groundwater Talk Live. I'm Tom Ballard, the groundwater guy, and today we're going to be talking about, we're going to do an introduction on data-driven decision making for small water systems. So really, uh, water systems probably are one of the most data-intensive industries out there. So it can really stand to benefit from the data-driven decision making models. So, and even we've gotten to the point now with AI and some of these things out there that even the smallest water systems can take advantage of this. So we're really focusing. What we focus on here is small water systems, and that's what this talk is going to talk about today. Is really these benefits of data-driven decision making for small water systems, really focusing on small water systems. So, what is data driven decision making, or DDDM for short? At its core, data driven decision making is an approach to business strategy that relies on verifiable data to make informed choices rather than intuition, anecdotal evidence, or past experience alone. It involves collecting, analyzing, and interpreting data to gain insights that guide actions and improve outcomes. So we collect a lot of data as a small water utility, and a lot of times it basically gets filed into a filing cabinet. And so this is something that we can take that, we can digitize it, we can use it to analyze trends and really use it to its maximum effect. We've already spent a lot of money to collect this data, so let's use it to maximum effect and go from there. So water systems stand to generate substantial gains in productivity and financial efficiency through the use of data-driven decision making. Few businesses are driven by data the way water systems are, as I already indicated. There's a lot of data out there, whether it's data coming from the SCADA system, whether it's the well data, whether it's compliance data, basically customer service data, whether it's analyzing for contaminants and bacterial samples in the water treatment plant. There's a lot of different things where we're collecting data, and we need to use that to its maximum effectiveness. And that's what data-driven decision making is really all about. So this is really kind of a little chart here that just shows what some of the benefits are. And we're going to run through this real quick, just going clockwise. So number one is improved efficiency. So we're taking this data and we're using it to improve our efficiency, optimize our water production and distribution processes through the use of proper data. Now, a lot of the data is going to be used to analyze trends. That's probably the biggest use of the data, not just isolated data here and there. And that's why just shoving in a filing cabinet doesn't work. You want to take all the data together and look and see what the trends are. And that's going to be important, and that's going to help us improve our efficiency. Enhanced asset management, collecting the proper data to determine the criticality, probability of failure of our assets is really going to be important to proactive maintenance, and we'll talk a little bit about predictive maintenance even, and extending those asset life cycles. So this is really important because we're going to use data to do that. And instead of taking a reactive approach, now we're going to be proactive in our asset management. Better water quality, ensuring compliance, and optimizing treatment processes. So you got to collect a lot of data for the regulatory agencies. We want to analyze the trends so that we don't get out of compliance. We're not exceeding MCLs, things like that. So we want to look at the trends and see when we might be approaching that and make sure we don't get there so we don't get any fines or violations. Effective customer service is probably an area that most people don't think about for doing data-driven decision making, but customer complaints really can help us analyze different parts of our system and understand what's going on. For instance, if you have consistent complaints about water pressure, drops in a certain part of your system in a certain pressure zone, then that can really lead to determining what is the cause of that. And maybe we have some components that are looking to fail over the near term, and that's something we can address right up front. And the customer service complaints or the customer complaints can really drive us to that. So this is an important part of the process too. They're not just complaints that need to be dealt with and filed away. It's like, let's put them together, see what the trends are, and determine if it's really telling us anything. Informed capital planning, we want to align our investments with long term goals. So, our capital improvement plan really needs to reflect our investment in the long term success and efficiency of the water system operations. So, we want to provide enough money for the capital projects. We need to maintain things, replace our assets when they need to be replaced on a schedule to make sure that we're not getting breaks and breakdowns in our system when we least expect it, because those are going to be the most expensive types of repairs. Obviously, regulatory compliance, we talked a little bit about that under water quality, and there's a lot of different filings that water systems need to do for regulatory compliance. It's not just doing your back T samples. There's a lot of other things that need to be done. So by putting all that data together and seeing what our trends are, once again, we can maybe stay out of hot water and avoid fines and violations. All right, so those are the benefits. So what types of data sources do we really use when we're talking about data-driven decision making? So often most of the data needed for a data-driven decision making is already being generated. We're generating a lot of data every day in a water system, but like I say, it never gets put together. It's in data silos, they call them, where there might be some over here, there might be some over here, and we're not putting it together to more efficiently manage our system. So we're probably already collecting a lot of the data we already need, but it's not being used systematically. For example, let's look at lab reports, for instance. We may get them in hard copy format, or we may get them emailed in a PDF format, but we may print them out. We may look at them, make sure we're in compliance and nothing's going anywhere or askew, and then we file them away and never look at them. And once again, I'm going to go back to the fact that we need to take this data and start looking at the trends. So if you are monitoring arsenic, for instance, in your system, then if we're seeing a steady increase approaching the MCL for arsenic, we really need to investigate that. And without looking at the trends there, looking at isolated data reports or lab reports, we're going to say, okay, we are in compliance, and so that's all we need to know. But if those numbers are creeping up there, we need to start investigating before we have an MCL violation. In some cases, additional data collection may be necessary. That may be manual. It could be IoT sensors, and IoT stands for Internet of Things. And really what that means is these are going to be interconnected sensors that may be on valves or pressure sensors or flow sensors, where we're looking at that. They're going to be connected to the internet. They may be connected into your SCADA systems. SCADA systems now are collecting a lot more data than we used to use them for, and they have the capacity to do a lot there, be the central hub basically for your data collection. So by having IoT sensors out there that are now running through your SCADA system, you can now get basically real-time data that's coming in that you can analyze, and now you put it in a spreadsheet and start tracking those trends, and you can make some pretty good decisions that way about what's going on operationally with your system. Also, GIS data is another data. Where are your assets located? You want to have that nailed down pretty good, because if you need to replace the valve, if it's scheduled to be replaced, you don't want to have a GIS location that may be within 100 feet, where you're going to be doing a lot of digging looking for that particular asset. You want to nail that down. You want to have that in a database. You want to have some pictures attached to that. This is all data we can use to properly manage our assets. All right. So this is a look at where our data sources come from. So once again, let's go clockwise around here. So our water production data, information on water source levels, treatment plant operations, things like that, is really the production part of it. So your treatment plant, where your source is, and your treatment plant. That's the data we're looking at. Next up is water distribution data. So this is water in our distribution system, and that's data on water pressure, flow rates, pipe condition, and also basically this water loss can fall into this area too. So non-revenue water can fall within the distribution data uh, area. Water quality data, that's going to be your back T samples, your other samples for any potential contaminants, and all the regulatory monitoring that you do, plus any other data you collect that might not be required by regulatory agencies, but you collect to make sure your system is operating properly and you're maintaining clean water. So once again, you're going to want to look at the trends on that, and you need to pull that together. So and put it in a form you can analyze it and look at the trends. Generally, that's going to be in the form of a dashboard type of situation. We'll talk about that a little bit later. Customer data, once again, we talked about um, the customers. Basically, customer complaints, yeah, everybody doesn't like them, but this is something that we can use basically to look at our system or at least improve our service. We talked about, maybe pressure loss here can point to some things, but just if we have some complaints about things that are consistently showing up, then that's probably something we need to address. So you look at the trends there. Financial data, information on revenues, expenses, and capital investments. So a couple things here. One is that financial data is really important for understanding your rates. Are you charging the proper rates? Do you need to go for a rate increase? And then looking at capital investments, we want to replace those assets on a schedule before they become a problem. As we talked about, the most expensive repairs are the unplanned for repairs because they usually happen at midnight on Christmas Eve or things like that. So that's going to be expensive. So we want to make sure we have a capital improvement plan in place that's going to be fed by data that's going to give us solid information on what the costs are, when they're going to need to be spent, and what assets are going to need to be replaced. And speaking of assets, asset data, details on asset location, age, and maintenance history. This is going to help us establish the condition of that asset, the criticality of that asset, the likelihood of failure, and basically that's going to feed back into the capital improvement plan on when we're going to need to replace that asset. And last, kind of a catch-all here is SCADA data, looking at data from systems monitoring and controlling water systems. A lot of people are running a lot of stuff through SCADA systems now, so they're much more robust. And for small water systems, a lot of the SCADA data is now kept in the cloud, so you can access it from a cell phone or an iPad, and it becomes easily accessible information to help run your system from wherever you are. So you don't need to look at the control panel in the control room at the treatment plant. You can look at it now on your cell phone, and that's going to improve things. But now the data that's coming into the SCADA system, that's going to be kind of a central hub or a clearing point that's going to come and basically give us our data coming in near real time or real time, and then we can actually set up systems to dump that into spreadsheets so we can do the analysis, analyze the trends, and you can kind of see the pattern here. We're starting to look at how we can use this data to maximum effectiveness for our water system. So then I think this is kind of just a simplified version of that data sources thing. If somebody wanted to take a screenshot, this just kind of gives you an idea of where the data is coming from, just the different sources. So, so it's basically the same thing as before, just without as much detail, kind of simplifying a little bit for you. All right. So, implementing data-driven decision-making in water utilities, this is the roadmap. So we're going to spend a little time with this because this is a step-by-step process for implementing data-driven decision-making in small water utilities. And this is really focused on small water utilities once again, but pretty much the same path for larger water utilities. We're just kind of making some concessions to the financial constraints that small water utilities might have. So first off, we want to start off over here on the left-hand side. We want to start off small. So we want to begin with a pilot project in a specific area, work any bugs out, see how things go, and then start expanding out from there. So it's going to be important to start small, make it manageable, get people used to it, and now we can start expanding out as we kind of tweak things and hone things a little bit as we go along. So next up is identify KPIs. KPIs are key performance indicators, and they are basically going to give us our goals and basically a measurement tool for determining what we're are we reaching our goals and what the trends are showing us. So basically that could be you know, the amount of water loss or percentage of water loss over time. Our goal is this much. Our KPI is going to tell us, are we meeting that goal? Something else might be for our certain maintenance requirements. So how much are we spending on maintenance and or pump performance? These are some KPIs we can build. I did a whole video on just doing KPIs for different water systems, but basically they are a measurement tool we put in place fairly early on so that we can actually measure that performance, and it gives us numbers we can actually look at and then compare over a period to determine how we're doing. Next up is assess data availability, determine available and needed data sources. So we talked a little bit about data sources earlier. We need to assess that, make sure we're getting all the data we need to make the decisions we're making, and do we need to fill in any holes? And that's going to be the next step here is invest in technologies. You're probably going to need to acquire some sensors, that's IoT sensors and meters for data collection. So you're assessing data availability. You're going to look at the gaps, and then you're going to need to determine what technologies you need to invest in order to get the data you need to make the proper decisions for this part of your system, and start expanding out from there. So you're going to probably want to start for the technology part in critical parts of your system or where you really need to have the data, and then just expand it out from there as the capital becomes available and you budget for it. And then we want to develop a data plan, create a plan for data management and security. So you're going to want to start consolidating your data, how you're going to handle it. But a big one these days is cybersecurity. Not only physical security, but cybersecurity. And I can tell you that small water systems are not immune from cyber attacks. So it's really important to understand, and that your staff understands, that securing your data is really, really important. Most of the attacks and successful attacks from on a cybersecurity situation are going to be from staff being tricked into giving out passwords or letting people in and looking for weaknesses in the system that way. So you're going to want to train your staff so they understand that, which is part of the next component is provide training. So not only cybersecurity, but how are we dealing with the data? So we want to train the staff on the analysis, how we're going to do it, and the data flow process where the data comes in, how we process it, how we track the trends, and how we make it available to everybody that is in a decision-making role. So staff needs to understand that so that we're always keeping that flow of data going so we can make timely decisions. And for small water systems, start off using simple tools. There's a lot of really sophisticated and I might say expensive software out there for doing, say, predictive maintenance, asset management, and things like that. Most small water systems are not going to need that. Using a simple spreadsheet and open source software will do it. For instance, say you want to track some trends and do some analysis, you can take Google Sheets, for instance, which is generally free online. You can plug it in, and you plug your data in. You can, and then you can use the Google version of AI, which is called Gemini, and you can ask it questions and have it produce some charts and some analysis for you of the data you have, quick and easy. It's just a matter of writing the appropriate prompt to do it. And, then you can, that's a simple tool, but it's very powerful and it's quick and easy to do. So once you understand it and do it a couple times, then it becomes old hat. So you don't need the really sophisticated and really expensive software to do a lot of these things and get a lot of the benefits of data-driven decision making. Okay, next up is collaborate with utilities. So you're going to want to find your neighboring utilities, other utilities. You want to share data and best management practices with other utilities. One of the ways to do this, and something we work on people with, is through a mastermind where you pull some different people together. You meet maybe on a monthly basis, maybe get a little bit of training, and then you share best management practices, lessons learned, those types of things, so that you can go back and now take and get the benefit of other people's experience and share your experiences with them too, so that you're all going to be better. So don't just silo it and isolate yourself. Share with other people, because it's just, especially when you're talking about AI types of things, it's a rapidly moving field and changes are quick, and people are doing different things that they weren't a few weeks ago. So keeping up with that is challenging under the best of circumstances. But if you can share data with other people, that's going to help keep you on track and and maybe think through some things. So seek external support, whether that's through regulatory agencies or consultants, is to help steer you on these things and get help where you need it. Don't not do something because you don't know how to do it. Look at a consultant or the regulatory agencies to help you. And also it's helpful to talk to the regulatory agencies and tell them what you're doing by implementing data-driven decision making, so that if you get a little glitch here and there and maybe your reporting doesn't go quite as well as it could, they will understand that you're in the implementation phase and probably cut you some slack on that because you're trying to improve your operations. So important to get the help you need and to keep the regulatory agencies abreast of what you're doing. Next up, we want to visualize the data, and that's a little bit what I was talking about with doing the AI analysis of the numbers. You want to, the human brain thinks in terms of pictures a lot of times. So we can look at, the rare person is one that can look at rows and rows of numbers and just have it instantly make sense. You can try to discern some trends, but really converting that data to pictures in the way of charts and graphs is really going to make things hit home and allow you to analyze that data much more effectively than you could just looking at rows and numbers. AI can help you do that. You can just say, okay, compare this field versus this field, and how are they tracking against each other? Draw me up a chart and let me know what your analysis is and what trends you see. Boom, you're done. And in 5 minutes, you got a really nice analysis that you can report back to the board on, and really helps you make some solid decisions because you're analyzing the data and you don't have to spend hours of it on your own. You can let AI, that's a mundane task, you can let AI do. So that's where AI really, its strength right now is doing some of these mundane tasks like data analysis. converting it to visual data. All right, you want to document your processes, and this is going to be, record data collection and decision making. So basically, what you're going to want to do is generate some standard operating procedures or SOPs. So you bring new people on board, they can track things. You're going to start doing things the same way every time, and that's where an SOP comes in. And lastly, this is an iterative process. So you're going to want to review and improve. And it keeps cycling through. So you're going to want to review and improve, review and improve. You always want to be looking at where you can tweak things to make it better as new tools come out, as new software tools come out, as AI advances. You can incorporate that into your program and keep improving it so you're making the most solid decision possible based on the data you have and your analysis of that data. So this is the roadmap that works. This works for large utilities, small utilities. We're making some concessions here for smaller water utilities, but you can see this is really within reach of even the smallest water utility now. It's cheap, but the benefits are oh so great. All right, so here's some examples of data-driven decision making, and we're going to kind of go from the from reactive to proactive. Probably leak detection is the most reactive mode we have right now. So we're analyzing water production and consumption data to identify areas with higher water loss or high water loss and prioritize leak detection efforts. So you're really looking for leaks and try to stop that non-revenue water, which is important because non-revenue water is a huge deal for most water systems because you're paying for that water, you're not getting any revenue, and it's basically is money that's flowing out of your bank account and into the ground. So you want to deal with leak detection, and boy, there's just so many ways to do this. There are listening devices. We're seeing now that there's actually satellite leak detection that's actually fairly affordable, even for all but the really smallest water districts. There's actually more accurate than a lot of these listening techniques, and so it can be a great tool, especially if you have some significant problems with aging infrastructure and non-revenue water. You really look at some of these tools, data-driven tools for doing leak detection and stopping that non-revenue water. All right, next up is pump optimization, analyzing pump performance data to optimize pumping schedules and reduce energy consumption. One of the ways to do that is wire-to-water efficiency calculations, which can optimize maintenance schedules. You're really looking at how efficient that pump is, and this can be done. You can collect the data once again in real time through your SCADA system and start doing some of these calculations. And you can look and see what your wire-to-water efficiency is over time and determine when that pump is going to need to be overhauled or have some maintenance. Another way to do this is through vibration sensors. Obviously, a lot of these pumps run and they're rotating and they got bearings in there, especially on something like a line shaft turbine. You start flat spotting a bearing, you're going to start seeing increased vibration. That is going to start causing problems and can result in catastrophic failure. But if we understand what's going on and we're starting to see an increase in vibration in that pump, we can do the maintenance before it becomes a problem, before things are shut down and those complaints start coming in because this part of the system has no water. All right, water quality monitoring, analyzing water quality data to identify potential contamination risks and optimize treatment processes so we can analyze trends in our residual chlorine. We can analyze trends in, and we already talked a little bit about arsenic or iron and manganese and see when we're starting to hit some of those thresholds where maybe we start to exceed MCLs or secondary MCLs, and we want to avoid that. So we want to look at the trends here. That's going to be most important. Not only the current data, but the trends on that data. customer service improvement. Talked a little bit about this earlier, but analyzing customer data to identify trends in service requests and to improve response times. This, beyond talking about the maybe identifying some system problems, it can identify some front office problems where your billing may not be going out on time or it may not be accurate. So by tracking customer complaints and service requests and analyzing that data and grouping it into trends and groupings, logical groupings, we can see where we got potential problems that we can go and improve. And everybody's all for fewer service requests and fewer customer complaints, obviously. Probably the biggest aspect of data-driven decision making, and this is something I've talked about in a previous video, is predictive maintenance. So analyzing asset data, predict equipment failures, and schedule maintenance proactively. So the key here is this is proactive, and this is about as proactive as you can get. This data can mean substantial improvements to asset management plans and capital improvement plans, because we are now have a system in place where we're predicting maintenance requirements, predicting failure modes for a lot of our equipment, and we're able to maintain and replace that equipment ahead of time. And that keeps us up and operating, reduces downtime, and minimizes repair costs. Now, obviously, that's going to need to be supported by the asset management plan and the capital improvement plan, because we need to have the money there in order to replace things properly, and that's going to flow from the asset management plan. But it all works together, because this is kind of a go back to the beginning and start over again, because you're looking at feeding data into your asset management plan, which feeds data into the capital improvement plan, which then provides funds for the maintenance of the equipment that's generated by the predictive maintenance. So I have a whole video on predictive maintenance, and so that's really important. And this is an area we can really see some gains, 20 to 40% by some estimates. You can see gains in operating revenue, saving costs 20 to 40% by using predictive maintenance, by staying ahead of the game. So very important. All right, so data analysis applications range from reactive to proactive. We talked about leak detection probably being the most reactive, because you spring a leak, you got some non-revenue water issues, water that's not accounted for, you probably have a leak, you need to track it down, so that becomes reactive. We go all the way down to the other end of the scale, and we're talking predictive maintenance is really the most proactive you can do, and things we like customer service, pump optimization, water quality monitoring. This is stuff that's kind of in between, but the whole goal of data-driven decision making is to push things more towards the proactive end of things. Because if we can be proactive on this thing, we're going to have less problems, and less problems is going to be less unintended expenses. That's going to save us that 20 to 40% we were talking about on the predictive maintenance, and really see the benefits in our our budget and our finances. So that's really a big component. We want to push things over to that proactive end of things as much as possible. All right, with a lot of things, there are challenges to implementing something like this, and anytime you do something relatively drastic, there's going to be some challenges. And I look at it like an iceberg here, and that's our illustration. Is we got most of the iceberg is below the water, but we have that visible part above the water, and that is the fact that most small utilities, water utilities, are going to face resource constraints. There are limited resources, limited finances, and so we got to make this work with the finances we have. And as we see the benefits over time, that situation is going to improve, but we need to go in this being realistic about the resources we have and the time frame we can implement this. Now we get down below the less well known or seen things here, and we look at lack of expertise. So, in some cases, our staff may lack data analysis skills, so we're going to need to fix that. Um, Data silos, we talked about a little bit earlier. We may have some data over here, we may have some data over here, we may have some data stuck back at the treatment plant and some of the main office, and we need to get all that data together, get it into a computer, get it into spreadsheets and databases, and start looking at that data and analyzing the trends. So data silos basically just need to go away, and we need to overcome that particular challenge. Aging infrastructure means that we may not have the tools we need to get all the data we need. This is part of that getting your technology up to date, and we're going to have to start budgeting for that and start replacing things and get those IoT sensors out there so we can now start connecting that up to our SCADA system and get that data in so we can start analyzing things in real time. But when you first start out, you may not have those capabilities, and that may be a limitation for you. Data quality issues, there's good data and there's bad data. And so you need to improve the quality of your data. So just writing down estimates and things like that, it may be as good as you can get right now, but we need to start looking at how can we collect hard data that's accurate, that's going to allow us to make the best decision possible. So, so that's one of the challenges we have, and probably the last but not least is really resistance to change. That is a real thing. Is people have been doing things the same way for 20 years. They don't want to change, and they know they need to change. They know what the benefits are, but there's certain resistance to change, and you're going to have to overcome that. One of the ways to do that is to chunk this stuff. And like we said earlier in the implementation plan, is to start small and to basically start doing it incrementally so people can see the benefits with their own eyes, and you can then start to roll it out to different areas and instead of doing it all at once. The data is that the resistance to change also often torpedoes company programs that people have these ambitious plans. They roll out these big programs that represent radical change, and they fail. And they fail because of resistance to change. People don't like that much change. So you got to break it down into smaller components. Yeah, it may take you a little more time, but by getting staff buy-in, you're going to be better off in the long run, and you're going to overcome that resistance to change. So these are some of the challenges you need to be aware of that you're going to face in implementing this program. But all these things can be overcome. You just have to approach them in the right way, recognize they're there, and approach them in the right way. All right, so for small water systems, data impacts nearly all the attributes defined in the systematic utility management approach to water system management. Data-driven decision-making approach is really ideal for a small water system just because of the vast amount of data that we collect and use. So by having a systematic approach to using that data, analyzing that data that DDDM gives you, that's going to really go a long way to seeing more efficient operations at that water utility. And so let's look at, and these are all the attributes of systematic utility management. This is sometimes called effective utility management, but you can see the 10 components here, and this is basically all the various components that affect a water system. So product quality, operational optimization, infrastructure strategy, community sustainability, stakeholder support. All these things are impacted to some degree by the data you generate, and the data can be used to improve every one of these areas. I know 10 areas sounds like a lot, but this is really what you're dealing with when you're a public water system you're dealing with the customers, you're dealing with the public, stakeholders, you're still trying to operate things, you're dealing with staff. These are all different areas, and all the infrastructure you have, data affects every single component of that. So, so this is important to realize that there are very few areas, if any, in a water system that are not impacted by the data. And if they're impacted by the data, they can be improved through a system like data-driven decision making. All right. So, in conclusion, for a small water system, data-driven decision making is about using the information you already collect, augmented by affordable new tools to solve problems faster, optimize operations, reduce losses, improve customer service, and plan smarter capital projects. DDDM turns data into daily management assets, not just a compliance requirement. So think of your data as an asset, as a valuable asset, and that's really where we're going with that, because it is something that can be used every day to improve operations. And the more you do it, the better you get at it. You go through that iterative process, and you're going to see the benefits of data-driven decision making on the business. All right, that is our show, and thank you very much. If you enjoyed the show, please like, share, any comments. My email is there. If you have any questions on this, please let me know. I'm going to be doing a talk at the in September at the National Rural Water Association Water Pro Conference in New Orleans on data-driven decision making. So we're going to dive into a little more detail there, but this is basically just an introduction here, but hopefully you can see the benefits. So thank you very much, and we will see you next time.